All right, so we're going to talk about the 6 trig ratios. In geometry, you dealt with 3. We're going to add on to those 3. So the 3 that you had before were sine, cosine, and tangent. Right? In a right triangle, what we're going to have to do is we're going to have to designate one of the angles as like the angle we're talking about. Most of the time, that angle is referred to as theta. Okay? Once you designate which angle you're talking about, theta, it is never the right angle, by the way. It is always an acute angle. You're then going to label the side. So this would be the opposite side, adjacent side, hypotenuse. Adjacent is an English word for next to. The side next to theta that is not the hypotenuse. The hypotenuse is always the side across from the right angle. Right? So once we designate OA and H, we then can set up our 6 ratios. So some of you have heard of SOHCAHTOA. I didn't learn it until I came here, so it's not something that's used universally. It is an acronym to represent the correct ratios. So sine is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? Those 3 equations are ones that you should have worked with before. We now have 3 other ratios that relate directly back to these 3. Sine, its reciprocal is called cosecant. The cosecant is going to be the hypotenuse over the opposite side. The secant is the reciprocal of cosine, so it's h over a. And the cotangent is the reciprocal of tangent, so it is a over o. I think tangent and cotangent sound enough alike, you know that they are related. Now, the reason I have these letters up here on the board, S, C, and T, is that whenever you're asked to do the problems in this section especially, I would write them in this same kind of schematic order. I wouldn't change the order up of these at all. I would do this in the 6 until you have them fully memorized. So sine, cosine, tangent. Sine, we say it's the reciprocal, so S is going to go to C for cosecant. Cosine is going to go to S for secant, and then we already know that tangent and cotangent are kind of related. So when you're thinking about this, even to this day, if you say to me, what is the secant? I'm going to go secant starts with S. S's opposite is C. Cosine is A over H, so I know it's H over A. I always go through that loop process to come up to here. Just because it links to something I already know. I have these memorized. I know this acronym now. So now I just have to say secant relates to cosine. They're opposite. I know, but they did. It would be a lot smarter if they didn't switch the letters up, but they did. Or called it like cosine. And this couldn't be cosine because that would be this already, and it would be a mess. Okay, so right now all I'm doing is I'm giving you the definitions. Now, let's talk about a trig equation. This is something that I think sometimes we skip over when we ask you to figure out these ratios. We go right to the fractions, but we don't talk about the significance of the equation. A few lessons ago, we added in exponential and logarithmic equations. We are now going to explore trig equations. Trig equations have 3 distinct parts. They have which trig function you're talking about. So now we have 6 to choose from. We have the angle name, whether it's theta, alpha, x, t. There's a bunch of different letters, usually Greek letters or English letters, that we use to replace to talk about which angle we're speaking about. And then we're going to set up a ratio of sides, O, A, or H, based on whatever trig function it is that we chose. So anytime you are asked to write a trig equation, it should look like this. You'll fill in the ratio, the angle name, and the 2 sides. Now these sides might be replaced with numbers for the actual lengths, but in your head you're always thinking about those variables that represent the sides. All right, so let's look at example 1. This is something you probably have done similar to in geometry. If I have a triangle, first of all, notice this is going to be my theta. They are giving that to me, theta. I don't know how big theta is. For this activity, I don't care how big theta is. We'll deal with that in a later lesson. As you can see, if this is theta, we know that this is the hypotenuse, this is the opposite side, this is the adjacent side. So as you can see, you're asked to find sine theta. In your homework tonight, you are asked to find all 6 trig functions. A trig function, think of an equation. Don't I take points off when you don't say y equals something? A trig function is an equation. It has the ratio, the angle, and the ratio itself that we're going to fill in as a fraction. So sine is equal to O over h. So I'm going to come over here. I'm going to say, okay, the O side is 2. What don't I have? Do I have the hypotenuse? Do I know what h is? 3. Perfect. Now I'm going to go to cosine. Cosine is a over h. Do I know what a is? No. So that means I'm going to have to calculate it. This is where those of you who are kind of like, how are you getting these sides so quickly? This is how. If I look at the hypotenuse as being here, it is 3. That is the longest side. So I'm going to take 9. I'm going to subtract 4, and I get 5, but I want to take the square root of that to get this. So it's 3 squared is equal to 2 squared plus x squared, which I am solving. Pythagorean theorem. We get x is equal to root 5. So now, my a value, according to here, is the square root of 5. I calculated that, and h is going to be 3. And tangent theta. Tangent is O over A. So my O is going to be 2. My A is root 5. Am I ever allowed to leave roots in denominators? No. So the final answer that you should have here is 2 root 5 over 5. Too fast or good? Questions? Take a minute, take a breath. Yep.
For cosine, how did you get square root 5?
Pythagorean theorem. X squared, a squared plus b squared equals c squared, correct? The key to doing Pythagorean theorem is always identify c. C is going to be the red line I drew, which is 3. So that's the 9, or 3 squared, is equal to a squared plus b squared. I just substituted in an x. So then I got 9 minus 4 is 5. 5 is equal to x squared. Take the square root of both sides. All right, so to answer another little question there, I know that I did that really fast, and I prefer you to ask like you did. The reason I asked you to do it quickly is because if I did it all by hand first, you would think on every problem you have to do that, and you wouldn't ever start to do the mental math behind it. Now you're going to start to pick up a little bit faster if you didn't recognize how to do it first. It wasn't that I was, trying to mystify you. It's the fact that we're going to get used to doing calculations like this in our head. So I just jumped right into it and then answered questions if you didn't understand. Now, as you can see, SCT, here it is, sine, cosine, tangent. Then right next door is where I put all my reciprocals, cosecant, secant, cotangent. The reason I do that is because I'm just going to take these ratios and reciprocal them. Take this and flip it over. So now cosecant is h over O, which is 3 over 2. Secant goes back to cosine, which is a over h, reciprocal h over a. So this is going to be 3 root 5, but I can't do that. So I turn it into 3 root 5 over 5. Cotangent is the reciprocal. I would probably go to the non-reduced form. 1 second. Root 5 over 2. Yes. Yes. Questions on that? This is basically today's lesson, what you're seeing right here. Okay? So it's the addition of the 3 ratios. It's finding the reciprocal, moving forward. At no point are we talking about angle size yet. All right, next problem. Guys okay? Everybody good? In the next problem, instead of a triangle, they're going to give you a simple statement. They're going to say this: tangent of theta is equal to 0.3. I do not like decimals at all when I'm dealing with my trig ratios. I would prefer not to have them. So my first step here would be to say tangent of theta is equal to 3/10. That would be my first step. The other option you do have is to turn this into 0.3 over 1. But now you're going to need a calculator, on and on, whereas in a fraction you wouldn't need a calculator. Hopefully, fingers crossed. So, after they give me the ratio equation, this is my starting ratio. So over here, I know that tangent is 3 over 10 because they told me that. I'm going to go and I'm going to set up a representative triangle. Here it is. And I'm going to pick a theta. So I'm going to call this theta. That makes this the hypotenuse, this the adjacent side, this the opposite side. Tangent, according to my ratio up here, is O over A. Opposite is 3. So now when I use my Pythagorean theorem, I don't have C. So I'm going to take 9, add it to 100, and get what? Square root of 109. Too fast or good? Take a minute. Ask your questions. Don't be shy. Once I have all three sides, I could always figure out all 6 ratios. So sine is going to be O over H. So 3 over root 109 is 3 root 109 over 109. What's cosine going to be? A over H. 10 root 109 over 109. Now, this is an example where we might want to follow that train of thought. Cosecant goes back to sine. Sine is O over H, so I'm looking for H over O. So that's going to be the square root of 1 over 9 over 3. Secant, square root of 109 over 10. Cotangent, 10 over 3. Good? Yes. You have to. It's a right triangle. We'll always use Pythagorean theorem to find the unknown sides. All right, key idea here, trigonometry is right triangle trigonometry. That's what we're doing right now. And even non-right triangle trig gets reverted back to right triangle trig. So, questions? Okay, example 3. As I promised, we're going quickly because it should be mostly a review. In example 3, notice I'm not asking you to find all 6 parts in the list. I'm asking you to find 3 parts. I'm asking you to find tangents in this case. I'm asking you to find secant. And then this one we're going to talk about because it looks tricky, but it's really not that bad. Okay? So, first thing, I'm told the cosine is 5 over 6. Representative triangle, let's pick theta in the bottom to be consistent. Adjacent, opposite, hypotenuse. Cosine is 5 over 6. A over H. Okay, so now I know my A value is 5. My hypotenuse is 6. How am I going to find the third side? Use the Pythagorean theorem. So I'm going to take 36 minus 25 and get what? 36 minus 25, mental math? 11, but I want 11 is equal to this side squared, so it is the square root of 11. Now, I understand that that calculation is probably going to become very easy for some of you. This is the part that scares people right here. Cosecant of theta is 6 root 11 over 11. That's such a big number. Why would we deal with that? Oh my gosh, that's ridiculous. I don't think I need it. I'm just going to skip it. Well, here's the problem. I could technically just give you this, so I want to give you an explanation now. Okay? If you have cosecant, first of all, cosecant is a ratio of what? Going back to the one that starts with the letter S. Cosecant goes back to sine, so sine is O over H, so cosecant is H over O. If I have a root 11 in the top and an 11 in the bottom, if I unrationalize this, doesn't that give you 6 over root 11? They're the same thing in a different form. So my hypotenuse should be 6. It is. What is my opposite side? Root 11. We're going to have to be able to work between the rational form and the non-rational form, where we have the square root in the denominator, and recognize that they are the same thing. That is going to become a key skill in this unit. So I'm introducing it now. Okay, I know you could do the problem without doing that, but that's what we want to do. Now, it says to find tangent of theta. So tangent of theta is equal to, this is going to be a ratio, O over A, root 11 over 5. And I'm done. Secant goes back to cosine. Cosine's A over H, so this is going to be H over A. So the hypotenuse is 6 over 5. As you can see, not a lot of calculations involved, just the Pythagorean theorem, but you have to start to memorize these new ratio definitions. Yep. You don't have the question in there? All right, what do you have? It's not a random page. Oh, it's blank. Okay. That's weird. So there's a blank page and then that one?
It's a separate page from my first. What we were working with.
Oh. Okay, so just put it interjected a blank page in there. That's basically it. Yes? There was no blank page in there, because didn't that throw off, like, normally we try to do the first page of the notes on the front, and now isn't it on the back of that?
Yeah.
And why would there be a blank page randomly in there? All right, we'll take a minute and catch up. I'll give you a second. Find the page in your notes, fill it in. I'll have to edit some video. Question, Greg? No, we're good? Be okay? Not okay? Need more time? I didn't think that. Saw my big long flowing hair and my short black dress. Same exactly. Same exact. All right, all caught up? No? All right, it's time to start reading some trigonometry terms, and it starts with letter C. Right? I'm going to redraw this triangle a little bit bigger just so that we understand what's going on. Here is theta. Here's this. Let's play a game. Let's say that theta is 10 degrees. I'm just going to make it up. If this is 10 degrees, how much is the other angle at the top? How did you get it? 90 minus 10 degrees? Yes? And we all agree, according to the diagram, theta is this, right? Minus theta? Anybody confused on me drawing this up here? 90 minus 10 gave me 80. So 90 minus instead of 10, I'm going to just call it what it is, which is theta. So when I look at example C and it says, tell me the sine of 90 minus theta, it means I don't want to know the sine of theta. I want to know the sine of this angle here, the opposite angle. It's a tricky mathematical way of saying what is the sine of this angle. So if I look at this triangle, which has the same lengths as what I already found, what switches in it is the fact that I'm going to erase this 80, is that now if this is the angle I'm talking about, not theta, I'm talking about this angle, this is the opposite, this is the adjacent, and this is the hypotenuse. So what is the sine of this angle? 5/6. Whoa.
Oh.
Do we get it or no? Okay. Let me ask you this. This is always my counter argument. If you come to a test and you see this, let me erase the purple. If I wanted you to find the sine of theta, wouldn't I just say find the sine of theta? Why am I telling you 90 minus theta? Because I want you to switch the angle. I don't want you to find this angle. I want you to find the one at the top. Okay? And if we switch our focus to the one at the top, this is no longer the adjacent side to the angle that we're working with. We now call this the adjacent side and this the opposite side. So when I'm asked to find the sine, I want the sine in this triangle here, where this is the angle I'm talking about, so it's the opposite over the hypotenuse of that triangle focused on that angle. Yes or no? Where's the confusion if you still don't get it? Go ahead. I can see it. They're going to give you that because they want to make sure you understand how to read the notation. If I wanted you to find the sine of theta, I would say just find the sine of theta. 90 minus theta means find the sine of the other angle. No, because how did we calculate this? If this was 10, didn't we take 90 minus 10 to get that one? So 90 minus theta could be any size angle in any triangle, meaning the other angle. All right, last part. Last part. Boom. Here's an example. This is homework number 43. This is a problem that you're going to have for tonight's assignment. The sine of 60 degrees is √3/2. What type of triangle do I always draw? A right triangle. Fantastic. So I come over here, I draw a right triangle, and I'm going to call this theta. The sine of theta. Okay, well, what's the size of theta in my given information? 60 degrees. So I can even note that in here. Here's 60 degrees. Is √3/2. Where do I put the √3? Where do I put the 2? This is O, this is H, so √3 over here, 2 over here, correct? Yes? Okay, now, for the sake of the video, and those of you that may go back and rewatch this, I'm going to call that √3. Can you tell me the length of the bottom? 1. Is it 1? Let's see. If I do a quick calculation up here, I'm going to get 4 minus √3 squared is equal to x squared. X is equal to 1. Yes? Longest side minus the other side squared. 2 squared is 4. We good? Okay. There is a reason why I did not label this OA and H. Okay? If this is 60 degrees, the other angle is how much? 30. So I'm going to erase theta for now. This is 60, this one is 30. I based my triangle off of the information I was given about 60. Now I'm going to move down here. What is the cosine of 60? Cosine is A over H. So what's cosine going to be in my triangle? A is, what's A? 1. And what's the hypotenuse? 2. So my cosine of 60 is going to be 1/2. All right, now, this is where the switch up happens. Just like the last problem. Am I still dealing with 60 or am I switching? Switching, be aware of that. And now I'm going to look at 30 degrees. If My focus is on my thumb at 30 degrees. Tangent is O over A. What is the opposite side to where my thumb is at 30 degrees? 1. And what is the adjacent side? Root 3. So it starts off like this, but then of course we have to rationalize it, which gives me root 3 over 3. Then I can go to the sine of 30. The sine of 30 is O over, what, H? What's the sine of 30? Opposite is 1 over 2. So the focus of O and A has to be the angle you're talking about. Does anyone have questions about that?